Modernage MCQs, Physics second year, year number 19, Atomic Physics, part 5. If 66 kilovolt is deployed across an X-ray tube, then the minimum wavelength of X-rays produced is option A 66 nanometer, option B 33 nanometers, option C 19 nanometer, option D 1.9 nanometer. The key is 1.9 nanometers. Therefore, the correct option is D. Reason: the energy of photon is hf is equal to VE or hc divided by lambda is equal to VE. The wavelength is lambda is equal to hc divided by VE, which is equal to 6.63 into 10 power minus 34, which is the value of h, into 3 into 10 power 8, which is the value of c, divided by 66 into 10 power 3 is the value of voltage applied, into 1.6 into 10 power minus 19 is the charge of the electron, or lambda is equal to 6.63 into 3 into 10 power minus 24 divided by 66 into 1.6 into 10 power minus 16, which is equal to 0.19 into 10 power minus 8, which is equal to 1.9 into 10 power minus 9 meter, or lambda is equal to 1.9 nanometer. Hence, the minimum wavelength of X-rays is 1.9 nanometer. Which shell is nearest to the nucleus? Option A, K shell, option B, L shell, option C, M shell, option D, N shell. The key is K shell. Therefore, the correct option is A. Reason: the shell with quantum number n is equal to 1 is nearest to the nucleus. It is denoted by K and known as the K shell. Hence, the nearest to the nucleus is K shell. The inner shell transition of electron in heavy elements emit. Option A, laser photon, option B, X-ray photon, option C, light photon, option D, gamma ray photon. The key is X-ray photon. Therefore, the correct option is A. Reason: A. When electrons jump from the metastable state to ground state, laser photons are emitted. C. When electrons jump from excited states of the atoms to state n is equal to 2, light photons are emitted. And D. When an excited nucleus of radioactive substance jumps to ground state, the gamma ray photons are emitted. Hence, the inner shell transitions of electron in the atoms of heavy element gives X-ray photon. They are called characteristic X-rays with transitions K alpha, K beta, K gamma, L alpha, L beta. Hence, the inner shell transitions of electron emit X-rays photon. The X-rays transitions K alpha is produced when an electron jumps to fill a vacancy in K shell from option A, N shell, option B, M shell, option C, L shell, option D, O shell. The key is L shell. Therefore, the correct option is C. Reason: A. The transition from N shell to K shell is K alpha. B. The transition from M shell to K shell is K beta. C. The transitions from L shell to K shell is K alpha. And D. O shell does not exist. Hence, the X-ray transitions K alpha is produced when an electron jumps to fill a vacancy in K shell from L shell. A photon of X-rays is deflected in magnetic field B at option A, theta is equal to 120 degree, option B, theta is equal to 60 degree, option C, theta is equal to 30 degree, option D, theta is equal to 0 degree. The key is theta is equal to 0 degree. Therefore, the correct option is D. Reason: the force exerted by magnetic field on a moving charged particle is F is equal to B V Q sine theta. The charge on photon of X is Q is equal to 0. The force acting on it is F is equal to BV 0 into sine theta is equal to 0. Therefore, a photon of X-ray is not deflected in magnetic field. Hence, the angle of deflection theta is equal to 0 degree. Laser is an intense beam of option A, monochromatic light, option B, monochromatic X-rays, option C, ordinary white light rays, option D, monochromatic gamma rays. The key is monochromatic light. Therefore, the correct option is A. Reason: when electron jump from metastable state of a substance to ground state by stimulation, the light emitted is intense monochromatic in the visible region. Hence, the laser is an intense beam of monochromatic light. The population inversion is achieved in a lasing material when maximum number of atoms are shifted in. Option A, normal state, option B, oscillating state, option C, metastable state, option D, excited state. The key is metastable state. Therefore, the correct option is C. Reason: A, in normal state, atoms do not radiate energy. B, the oscillating atoms do not radiate energy at constant temperature. And D, atoms cannot stay in excited state for longer time. Someone cannot achieve population inversion in excited state. The population inversion is achieved in metastable state because atoms stay for longer time in this state. Hence, the population inversion is achieved to shift atoms in metastable state. Which one of the following is produced by stimulation of atom by a photon of suitable frequency? Option A, white light, option B, X-rays, option C, lasers light, option D, gamma rays. The key is laser light. Therefore, the correct option is C. Reason: when an atom in metastable state is stimulated by a photon of suitable frequency, it jumps to ground state. The light emitted is laser light. Hence, the stimulation of atoms by a photon produces laser light. The highly unidirectional radiations are option A, thermal, option B, X-rays, option C, lasers, option D, gamma rays. The key is lasers. Therefore, the correct option is C. Reason: when an atom in metastable state is stimulated by a photon of suitable frequency, it jumps to ground state. All the photons emitted are unidirectional in visible region, and radiations are called lasers. Hence, the highly unidirectional radiations are lasers. An electron starts falling from fourth excited state to ground state. The number of the transition is option A 15, option B 10, option C 5, option D 2. The key is 10. Therefore, the correct option is B. Reason: the quantum number of fourth excited state is n is equal to 5 and ground state is n is equal to 1. Using the equation n is equal to n into n minus 1 divided by 2, the number of spectral lines is n is equal to 5 into 5 minus 1 divided by 2 is equal to 10. Hence, the number of transitions is 10.